Nintendo Switch, let me show you what's going on. We have several bent pins in the port, so we cannot do any further testing at this point. To plug power into this would be risking catastrophic damage. So we must disassemble down to the board level and remove the port and go from there. This video is brought to you by our friends at PCBWay. They got a special offer for you. I'll tell you about it in a bit. We'll be warming up these foam stickers at 130 degrees, 99% airflow. Unless they're really, really old and worn out, that temperature will typically get the job done. One of the major trip-up points for people new at this repair is this cable right here. Instinctually, if you've worked on anything before, you want to just flick the cable out. That is a really bad idea with this device. It will cause you many tears and pain. What you actually want to do is just back it out. There's two little notches right here. Just back it out, nudge it out, all the way out of the connector, and fold it over. If you do it this way, you will never bend a pin in that connector. We have the board out of the housing, and we're set up to remove this port. While I'm setting up my equipment, let me throw up my expected temperatures for this job. These temperatures are brought to you by the Amazon Associate links in the description. If you head to my video description and click on one of these links and buy any of this equipment, or if you buy anything during that session, a small portion of that purchase will go to supporting the channel. And I greatly appreciate you. It won't cost you an extra dime. For your orientation purposes, we'll be working on this area on the board. And our first task will be to flood it with some flux. Now we're going to mix in some low melt solder into these anchors to drop the temperature considerably. Now we're going to bring the sauce and drop this port right off the board. Like so. Another nice clean pull. As we're already on this side of the board, we're going to begin our testing right here. And these are the common failure test points on this side of the board, which is side A on the Nintendo Switch. The first thing we're going to test is the Pi 3 USB. And what we're going to test here is this big capacitor right here. And the line we're concerned about is the line that's going to the chip. And what we would like to see here is it not be shorted to ground. And it is not. That's excellent news. Now we're going to check our filters. What we want here is continuity going from the chip through the filter, basically to the port, but we don't want continuity going side to side. So far so good. And no short side to side. So everything is looking okay in the Pi 3 USB area so far. It can fail in ways that is not detectable with our current methods. Now we're going to flip the board over to side B, and these will be the zones where we begin our testing on that side. We'll start with the M92T36, work our way through the board to the MOSFETs and test pads, and then we'll work our way over to the BQ24193 area. As I stated, we'll begin our testing around the M92T36. First capacitor we'll be testing though is connected to the Pi 3 USB on the back through the M92T36. And the side we don't want shorted to ground is the side going to the chip. It should not be because it was not shorted on the other side. If it was, we'd have a definite problem. Now we're going to continue our testing, and we're going to be testing these capacitors and the lines going to the chip. This capacitor right here is an exception to the rule. It has two lines going to the chip. In that case, one side will be ground. As long as both sides are not ground, you're good. And this capacitor here is pretty critical. If it's shorted to ground, it's usually not a good sign for the system. So far, so good. We're going to move down the board to the MOSFET area. And nothing appears to be shorted there. Check our little filter. Same rules apply to this filter as the ones on the other side. Let's test our invincible fuse. Still being invincible. Now we're going to check our test pads. None of these test pads should have a pathway to ground. And none of them do. Neither of these test pads should have a pathway to ground. Same rules apply to the BQ24193 as the M92T36, except a few of these capacitors will have multiple lines going to the chip rather than just one. And everything is looking good. They've come a long way with Flex PCB. There are some devices with 8-layer flexes. PCBWay is running a promotion of up to 60% off their Flex, Rigid Flex PCB. $46.74 for 1 to 2 layer FPC and $204.70 for 4 layer FPC. Check out all these options. Click my link in the description and head over to PCBWay.com. Start your project today. At this point, it appears our only problem is going to be the port. So for your orientation purposes, this is where we will be working again on the board. We will begin cleanup The low melt we applied earlier will greatly assist with the cleanup of these holes. We're going to add a ball of solder to our tip and just lightly glide it over the pads here. Sexy. Same concept on the port. Excellent. Now we're going to flow the port back into place. Lots of air movement here. Bring the temperature of the board up enough to wet the solder. We'll hold it down until it dries. Let's check our visible pins. Sometimes when you're concentrating on this inner roll, which is the most important part, you can neglect these guys. Everybody's solid. Everybody has nice fillets. Looking good. Excellent. Add some flux. And that is excellent feed through. That is factory fresh. Next, we're going to clean out the board thoroughly and clean out the port thoroughly, and then we'll set up and do some power tests. I hope this video is being helpful to you on your repair journey. Just a reminder, if this is beyond something you want to try yourself, I offer these services. Just head over to micromage.repair, click on free quote, fill out the form, and I'll respond to you personally. We're ready for some power test. First test we're going to perform is with a 3.5mm to USB-C dongle connected to my bench PSU. What we want to see here is just a quick spike in amperage and back down on both sides. It'll let us know that it's seeing both sides of the charger. Now, this step is not always that reliable. Sometimes it plays up with the PSU and sometimes it doesn't. Sometimes it doesn't want to play nice. That's exactly what we want to see. See if we get it on both sides. We're hanging on this side, but that could be it playing up with the PSU again. Next test we'll be performing is with our modified iPhone Power Squid. We have retrofitted it with Nintendo Switch and Switch Lite battery connectors. We're going to activate using our OEM charger, and we're just going to plug it in and unplug it real quickly. Just long enough to activate. And what we want to see here is a steady climb in amperage with no hanging. That's looking good. Now while it's booted, we're going to activate our capture card and see if it's docking with our dongle. It's not docking on that side. Let's try the other side. And there we go. It is docking. Excellent. So right now we believe it's fully functional, but we'll reassemble it and perform some other tests just to make sure everything is copacetic and go from there. Now let's go over the next big assembly tip I can give you, and that is how to handle plugging the cable back into the board. What we're going to do is before we even put the board in the housing, we're going to plug that cable in. If you meet any resistance, stop. And we're going to make sure the cables we do not want underneath the board are pulled out. And you just snap the board in, like so. If you approach it this way, again, you'll never bend a pin on that connector, and you'll never have to change that connector. We're back up and running on its battery. Let's run it through a little battery of tests here. Make sure it's recognizing and charging my Joy-Cons. Also want to test Bluetooth. Bluetooth is working. It's picking up our networks. Excellent. Let's see if it's picking up our Street Fighter game. And it is. Excellent. Everything seems to be charging and working fine. If you found this video helpful, I think you'll find this next one helpful, and I'll see you there.